All right, for this section of 4.3, we're going to talk about inference for experiments. The main thing we're going to look at here is sampling variability and statistical significance. So sampling variability is referring to the different samples yield different estimates. Larger samples produce more accurate estimates. When you can take more from the population, you're going to get better results of what the whole population is wanting, right? And what all it's describing, rather than just little small samples. And the margin of error creates an interval of plausible values. Statistically significant is when results from a study are too unusual to have occurred purely by chance. Okay? So in a simulation right there, if it is too unusual to occurred purely by chance, then we're talking about in that little dot plot right there, if we have a little set up there, the proportion of dots is less than or equal to 5%. Therefore, that is statistically significant. If the proportion of dots is greater than 5%, then it's not statistically significant. So again, the proportion of the dots has to be less than or equal to 5% to be statistically significant. Those little bit, just talk about them and kind of go through some examples so you can see what it's going to look like. All right, so on this first part here, how much do National Football League NFL players weigh on average? In a random sample of 50 NFL players, the average weight is 244.4. So with this, the first question is, do you think that 244.4 pounds is the true average weight of all NFL players? And explain your answer. Well, I would hope that you think that's a little low compared to seeing all the linemen and linebackers and things like that are in football and NFL. So no, all samples are different, right? What if they took the 50 sample that they did to do that average and they just took all the wide receivers? What if they just took all the running backs? Of course it's going to be a lot lower. Those guys have got to be a lot more leaner and faster. As compared to if they took, I'm pretty sure, an average of 50 players as far as linemen, I imagine that average would be quite a bit higher. So again, no, all samples are different. Since we don't have the whole population, we don't expect the sample mean to be the same. So we're just taking 50 players out of the NFL. That's like not even one team to calculate for the whole NFL. No. So that is a very small sample from a very large population of the NFL football players. So I would hope you would not think that would be a justifiable answer as far as saying 244.4 pounds. If another random sample of 50 NFL players was taken, would you expect the average weight of it to be exactly 244.4 pounds? So if you took another sample of 50 players, and would you expect that average to be the same? I would hope not as well, because again, like we just talked about, that initial 50 players, you could have got all wide receivers or running backs. And yet the next sample you get, let's say by the random number generator, it picks a lot more linemen, in which case that average would go up a lot more, okay? So no, every sample has a different group of 50 NFL players, so we don't expect each mean to be exactly the same. Now, each mean may actually include the actual mean for them. That number may fall in there somewhere, but the actual overall number for the average is not going to be the same. So for number C here, which would be more likely to give an estimate close to the true average weight of all NFL players? A random sample of 50 players or a random sample of 100 players? And explain your answer. Well, remember, let's think about this, right? We just talked about having a little small group, right? Only 50 players. Well, don't you think if you get 100 players, it'd be a little bit more accurate, right? A random sample of 100 would be better, right? Larger samples produce more accurate estimates. Compared to that 50, which is a small little sample, 100 is going to give you a lot better scope on what the actual average maybe. If you do 100, then maybe you're not just going to get all linemen, all linemen, or maybe you're not going to get all wide receivers. You're going to get a good mix of them, right? So that would help out quite a bit. Let's go forward through a little bit more. So with this, some students at your school claim to listen to music while studying will help improve their GPA. So we're going to design a study to help discover if this claim is true. So here are 4 proposed studies for investigating the question of the day. Suppose we found that the mean GPA of students who listen to music is significantly lower than the mean GPA of students who didn't listen to music. What conclusions could we make? Can we generalize? And can we determine causation? So the first setup here, or proposed study, is to get all students in your statistics class to participate in a study. Ask them whether or not they listen to music whether or not they study with music on, and divide them into 2 groups based on their answer to this question. So if we were to do that, just by asking everybody in class if they listen to music while studying or not, would that be a random sample? No, that's a convenient sample, in all honesty, right? If I just ask everybody in class, just who I'm conveniently around. They're right there in front of me, you guys are right there, so I just ask you and get that answer. Now with this, is it a random assignment? No. I haven't randomly assigned, I haven't told anybody you must listen to music, you must listen to music, you don't listen to music. We're just asking what you actually do as a student. Do you listen to music while studying or not? So conclusion here, for the students in this class, there is a correlation between listening to music while studying and lower GPA. So with that, because we can't say it's a random sample, we can't say it's a random assignment, therefore we are going to simply go with, we're going to go on with a conclusion, simply saying that yes, if listening to music while studying, your GPA will be lower in this proposed study, right? So for number 2, select a random sample of students from your school to participate in a study and ask them whether or not they study with music on, and divide them into 2 groups based on their answer to the question. So a random sample of students, this is it right there in the problem, right? So yes, we had a random sample. Now did we do a random assignment with them? Did we then take and tell them what to do, to listen to music while they're studying or to not? No, we didn't. All we simply did was got a random sample and then asked those students that we randomly sampled what they did while they were studying, if they listened to music or not. So again, for the conclusion, for all the students from your school, there is a correlation between listening to music while studying and a lower GPA. So we'd be able to determine that by looking at that data. We'd be able to say that yes, these students who are listening to music out of our sample did have a lower GPA. Now granted, I'm not saying that is the case just off the study. If you remember from the initial problem, it said that it showed that they got a lower GPA if they listened to music. And these are just the studies we could go off to do that. So that's why these conclusions sound the way they do. Not saying that it will cause lower GPA for everybody, but according to the study and the problem, that's how it plays out, okay? So for number 3, get all the students in your statistics class to participate in a study. Randomly assign half of the students to listen to music while studying for the entire semester and have the remaining half abstain from listening to music while studying. So do we do a random sample? No, because I just took my class, right? So I just took the statistics class. So I didn't do a random assignment. I didn't say, a random sample. I didn't say I took a random sample from anything. I just used my class. And then it says I assigned, right? So did I give a random assignment? Yeah, because I told half the class to listen, half the class not, the other half not to. So with that, the conclusion for the students in the statistics class, listening to music while studying caused lower GPA. And the reason why I'm saying it caused that is because, again, of an initial problem, it says overall that it does, according to the statistics for this problem, prove that it lowered their GPA. So I could be able to verify that by doing that type of study in my class. On number 4, select a random sample of students from your school to participate in the study. So random sample of students. Randomly assign half of the students to listen to music while studying for the entire semester, and the remaining half to abstain from listening to music while studying. So right there, we say in the problem, we took a random sample and then we randomly assign them on either to listen to music or not. So yes, we got a random sample, and yes, we random assignment. So for a conclusion with that, all the students at your school listening to music while studying cause lower GPA. So therefore, in that end statement, we could say that yes, and the students at our school, that was a cause for a lower GPA. So again, let's go to the conclusions again. Initially, on number 1 there, with the study that we were planning on doing, we didn't do a random sample, and we didn't do a random assignment. So it just showed about our class I was talking about. So I was just talking about a statistics class, and there's a correlation between GPA being low and listening to music. In number 2, we did do a random sample from the school, right, but didn't randomly assign it. So it just showed that there was, at the school as well, there was a correlation between the lower GPAs and listening to music. For number 3 there, we didn't do a random sample, but we randomly assigned. So again, that just went off the students in my statistics class. It didn't go for the whole school. But in the end there, we actually had our causation, right? We could prove there by doing a random sample from the school, a large random sample, that the students at our school, when they listened to music, got a lower GPA. So again, it's just how the question is, or I should say the study is worded and how it is played out to determine if you can truly say it has an overall causation to determine whether or not that is true. So I hope that gave you a little bit of insight on what we're talking about with 4.3 and dealing with that. I'll see you next time.